Well, hi everyone, and welcome into Pushing the Limits. Today I have Dr. Christine Houghton to guest. I've been very excited about this podcast and been studying something that she's an expert in, which is sulforaphane. You may have come across this on your travels on YouTube and Instagram and so on and so forth. Dr. Rhonda Patrick talks a lot about sulforaphane. And sulforaphane is something that we make in the body when we have the precursors glucoraphanin and myrosinase, which are found in the cruciferous vegetable family. And today we're doing a deep dive into sulforaphane, what it does in the body. We're also talking about the Nrf2 pathway. And Dr. Christine Houghton is a wonderful she's a PhD in nutritional biochemistry and nutrigenomics. She has 30 years of clinical experience as well. She has a very much a food first principle in the way she approaches things. And some of her approaches have been, for me, quite an eye-opener and a change in the way I see things. She's a pioneer and educator in the sulforaphane and nutrigenomic space. And she's has a primary background in nutritional biochemistry, but she enjoys translating the complexities of the science into its core principles and ensuring that they're relevant to the needs of practicing clinicians. She's a really highly regarded global expert in the phytochemical area and especially in the clinical applications of sulforaphane. She's done 3 detailed scientific sulforaphane review publications that highlight the many clinical applications of this remarkable phytochemical. So what's really exciting about this is that it's not about the disease. She goes further upstream in the process and really looks at what cells need. How do we get our cells into a state of homeostasis? So I'm going to leave it up to her to explain all the details, but pay attention. This is for everybody with everything from gut issues, IBS, Crohn's, ulcerative colitis, celiac disease, SIBO, right through to, just dysbiosis in the gut, right through to things like Klebsiella, Morganella, through to Helicobacter pylori, right through to autism, diabetes, liver problems, kidney problems. Pretty much every system is impacted by this pathway. So when you upregulate the Nrf2 pathway, you can have a lot of downstream effects on many of these ailments that you may be suffering from, or one of your loved ones may be suffering from. And this approach, by going upstream, which she'll explain what I mean by upstream in the actual interview, makes everything so much more simpler. When you really think about it. So I hope you enjoy this episode with Dr. Christine Houghton. She's a superstar in the world of functional medicine and nutrigenomics. So I was really, really lucky to get a bit of her time. Before we head over to the show, make sure you check out everything that I do at lisatamati.com. And if you're watching on YouTube, I'd really appreciate you subscribing and hitting the notification bell. And if you're listening on the podcast, please subscribe and do a rating and review for the show if you don't mind. It helps us get found, and share it with your family and friends. We love putting out fantastic content. Lots going on in my world, and you'll be seeing a few new changes coming. We've got a new website in development, and we have a new company in development too, a new biotech company. So watch the space for what we're up to over here. We also have the hyperbaric oxygen therapy clinic operating in Owakura in Taranaki. And if you need hyperbaric treatments, please reach out to my team, support@lisatamati.com. We also have the health consulting. We also do the DNA testing, the epigenetic programs, and functional medicine testing. So lots going on, lots that we can help you with. Please reach out if we can do anything for you. Head over to lisatamati.com. Right, now over to the show with Dr. Christine Houghton. Well, hi everyone, and welcome back to Pushing the Limits. It's fantastic to have you join me once again for a fabulous episode. This is one that I've been excited to have for a number of weeks now and been learning a lot about. I have Dr. Christine Houghton with me, who is an absolute superstar. Welcome to the show, Dr. Christine. It's fabulous to have you here.
Thank you so much, Lisa, and my absolute pleasure.
You are a rock star in the shall we say, in the world of health and biochemistry, and your expertise is in the area of, you can probably give us a little bit of a background so that I don't butcher the your incredible record that you
Well, I
have.
was in clinical practice, practicing nutritional medicine for about 30 years. And in 2004, I moved out of clinical practice. I had no idea what I was going to do, but I just knew I didn't want to be chained to an appointment book forevermore.
Yeah.
And I got into research, and I've always been interested in food as medicine. That's always been my primary approach. And then as the years went by, we all got swept along by a lot of supplements. And once I got back into research and I started looking at the research that has been done on plants, particularly as medicine, I pretty much just reaffirmed what I'd always known, but now armed with 20 years of additional science. What changed a lot of this for me was in the early 2000s, the Human Genome Project was completed. And that's when we started to understand how cells really work, and the way they work is not exactly the way I thought they did when I was in practice. So there are a lot of things I would do differently now if I was still seeing patients.
Yeah. And one of those sort of paradigm shifting things was like the antioxidant. Like we had this theory that, especially 20, 30 years ago, that we have all this oxidative stress that we hear about in our cells that's causing damage to our cells. That's a bit more of a complicated picture than that. And then we have the theory that came along that if we threw a lot of antioxidants at it, the vitamins A, C, and E, and so on, we would be able to counteract that oxidative stress, and we'd be fine. We'd live a lot longer, healthier life. Why was that theory slightly flawed?
Yeah, that was one of the biggest revelations to me, and that shocked me when I found out, when I said we understood how cells work. Cells are constantly detecting their local environment. If they see some sort of a threat, see, inverted commas, if a cell detects a threat, it knows it has to turn on its antioxidant defenses. So we erroneously thought that because of the oxidative stress, as you mentioned, we should just dump as many antioxidants as possible into our cells. What that actually does is it masks those stress signals that the cell uses to pick up, to switch on its protective genes. And so that then helped us to understand why some of the clinical trials that have been done where athletes, for example, are given high doses, well, not particularly high, say 400 units of vitamin E and 1,000 units of vitamin C, and then measure their inflammation and metabolic markers. We found the athletes who were exercising and taking the antioxidant vitamins were much worse off than those who were just exercising and not taking any supplements. So that study by a German research group came out in 2009, and that kind of rocked the biochemical world. It hasn't filtered into the clinical environment as well as it should, but there have been studies since then. And when you understand that the cell has many, many mechanisms to detect the threats that are around it, and it uses those signals to switch on. There's about 250 protective genes, which are all governed by this one switch, which is in the cell. And taking large doses of vitamins, the thing about the large doses of vitamin supplements is there's no way you could practically eat that amount of food to get that amount of vitamin C or vitamin E. I mean, when we look at the fact that we need about 10 units, international units of vitamin E a day, and these studies are being done with 400, 800 units of vitamin E, that's a megadose, and nature doesn't work like that. So basically what I try to look at is to say, how has nature sustained humans on this planet for however many millions of years or whatever, and I'm going to try and understand how nature does that, and I'm going to try and mimic that. And that's what brings me back to this concept of looking at the signals that cells use and work out what foods can activate the signals. And that gets into the other part of my research. So I'm very involved in a branch of nutrition science called nutrigenomics. And that is nutra as in nutrition, food, genomics as in genes. So it's basically foods that talk to our genes.
Mm-hmm.
And so what we've learned over the last 20 years or so since the Human Genome Project is that there are certain foods which can activate switches in the cell, and that's what the cell uses to upregulate its own defenses.
So it's
And it
sort of
makes
going a
sense,
little,
doesn't it?
yeah, it does. And the food first philosophy that you have is makes a lot of sense to me. And the going upstream, really, isn't it? Of
It is.
like putting in an antioxidant, and I did have some specific questions which I'll save for last around certain antioxidants, because I'm trying to get my head around them. But having learned certain things certain ways, you're sort of like, but just like the Nrf2 pathway, if we dive into that amazing pathway that does this upregulation, this master switch, if you like, that goes and what was revolutionary to me when I was learning about this in your work and listening to you was that this really is coming at a level much, much higher. So one of my teachers had taught me about redox signaling, and that we have to keep the balance in the cell, and that when we chuck just lots of antioxidants, we're losing that balance. And so I sort of got that concept, but that you could actually go upstream by using this Nrf2 pathway and actually activate hundreds of genes that govern, I think, 2,000 enzymes and things in the body that do different things. That really is a barrage of defensive mechanisms. So we're sort of, I heard Rob Thomas talking on one of his lectures when he was discussing this about like it's well, no, I think it was one with Carrie Jones, where she talked about like the Christmas lights. Or you talked about the Christmas lights, where you actually turn one switch, but all of the Christmas lights come on. And that was a beautiful analogy for me, because that just went, oh, I get it now. So I turn this one switch, and then all of these downstream beautiful effects happen that have a huge effect on all systems and all cells of the body, which was this beautiful concept that I'm just like, wow, is this all we need then?
Well, the way I look at it, Lisa, is that when we're working upstream, and you're right, there's hundreds of protective genes that are switched on by this Christmas tree switch. That's in my book, Switched On, actually, that analogy of the Christmas tree. And you get it, and I think that helps to explain it. That mechanism is active in every nucleated cell in the body. So that means I don't care what your diagnosis is. You come to me and you go, oh, I've got Hashimoto's disease, my thyroid's not working, da-da-da. I don't care what your label is. Now, that's not because I'm being dismissive. It means that I have some fundamentals I need to address first that's governing all the cells of the body. And, of course, if we're talking about thyroid, I've got a whole endocrine system that's going to be impacted by this anyway. I don't have the ability to micromanage what's going in thyroid cells to that extent. So I go upstream, I fix those core processes, we restore homeostasis is the correct biochemical term. So we get that balance back. We're working in the gut, we're working in the brain, we're working in every system of the body, but I'm not targeting those systems individually. So when I go, okay, I think we've gone as far as we can go, and the patient says, yes, but I've still got such and such system. Now's the time that I then focus my attention on that particular part of the physiology and try and work out if there's something else going on that's quite specific to that organ system. It could be all sorts of different things. But to start there, I think just wastes a lot of time. It certainly wastes a lot of money on testing, because I see no point in doing all of this functional testing when the patient first comes to see me, because I've only got to speak to them for 5 minutes and find out what they eat and the nature of their lifestyle, that I know there's already things I need to fix. You don't have to tell me anything, but I need to fix these obvious things. And then we can talk about whatever you think brought you here.
Yeah.
So again, it's not meant to sound dismissive, but it's meant to say, if we're really going to address human cells, what's going on in one cell is pretty much going on in every cell of the body. So I'm just going to optimize that function.
Yeah, and
So,
optimize that cell. That's its cellular health piece, as opposed to coming in.
And that's the bit that I didn't know when I was in clinic. I just didn't know that. And it was a huge revelation to me to find that out. And that in many ways was the impetus to do a PhD in sulforaphane and nutrigenomics, and sort of to be able to drill down more into those mechanisms and understand them better.
Yeah, and that makes so much sense, because like it really does come down to the, you know, we're made of, I don't know, 37 trillion cells or something, and I don't think anyone's really counted. It's a lot, and if we can get those cells operating correctly, then we can get the organ operating correctly, the system operating correctly, the body operating correctly. So you're going right to the root of the, or the upstream, or however you want to see it, of those. And I love that idea of not having to work directly with this disease, therefore this BandAid approach, because that is the way most things operate now. Is you go, well, you've got a headache, here's a painkiller, rather than why have you got the headache, you know, and why do we need, and what is the root cause? And of course that is especially you know, clinicians that are early in their career, they, you know, the amount of testing that you can do in order to make a better picture for yourself makes it easier. But when you can find an approach like this, is why I was so excited about this stuff, was it's like you don't need to actually be a specialist in everything, in every system, and every organ of the body, in order to have a massive impact with a massive amount of people. And that's what got me quite excited about learning about this. And one of the key things that you talk about is, and have studied, is sulforaphane. And I really want to do a deep dive into sulforaphane.
Well, can before we get into that, just say something else in relation to the general topic of treating upstream.
Yeah.
I started practice back in the 70s, a very long time ago, and we had a fraction of the knowledge that we have now. There were very few supplements available, so we had to use food. So I know that food works, and patients got better. So fast forward now to 2023 and thereabouts, we've now got a whole host of labelled diseases I never heard of. We never had SIBO, we never had MCAS, we never had, we knew people had histamine intolerance, but we didn't make them cut out a long list of foods. And I sometimes now talk to practitioners that go, I've got a really complex case. My patient's got SIBO and they've got IBDC and I forget all the other things. What are all the labels that we use now? I didn't know any of those. NTHFR was the other one now. It's not a disease.
It's not a disease.
I've just been diagnosed with NTHFR. 66.6% of the population has on one particular aspect of NTHFR. How did my patients ever get better? I didn't have methylated folate supplements. What I had was whole grain cereals, nuts and seeds, green leafy vegetables, all of which are good sources of 5-methylfolate. So nobody tells you that now. The folinic acid and the methylated folate that people are using as supplements, that's what's in food. That's why my patients got better, and I never even heard of MTHFR, and nor had anybody else. So the thing about my current approach is I never had those labels. I didn't need them then. Why do I need them now? And what I see happening is patients going into economic burnout because they spend a bucket load of money on a whole lot of tests up front, which really don't solve the problem. So the only test that I'm kind of inclined to do these days is I'm quite happy to do a nutrigenetic test, because it gives me just a one-off impression of where a patient's genetic strengths and weaknesses might lie. That's helpful. I do like to look at urinary pH, because it's a good indicator of how much plant food they're eating. So I find that one useful. It's a test you can easily do at home. There are certain blood spot tests you can do now that look at vitamin D, they look at omega-3 fatty acids. I'm quite keen to look at continuous glucose monitoring as a 2-week trial here and there. So those are the sort of biochemical markers that I find useful. Most of the others I would never want to do up front. I might use them later on. As I said before, I've done everything I think I need to do and the patient still has a problem. Then we drill down.
Right. And then you wouldn't conclude the microbiome testing in that, you'd start straight with the, say,
Look, I don't do the microbiome testing because a sick person coming to me's probably got quite a perturbed microbiome. The couple of revelations that also came to me in the last 20 years is I learned that unlike what I'd been taught for years, if I give a probiotic supplement, that probiotic does not take up residence in the gut. It might do something useful in transit, but it never takes up residence. So that's not how I fix the gut. If I did a stool analysis today and I'd been eating a high carbohydrate diet, and then 2 days later I decide I'll have a high protein diet and I do another stool analysis, I get a totally different picture. So if I can change the microbiome with simple dietary changes a few days apart, what do I need to know there? So I don't. Again, I'd only be looking for a pathogen, which may need some intervention that's far greater than I'm able to do nutritionally. Most of the time, we're not dealing with pathogens. We're dealing with pathobionts, which are microbes that happily enough live in the gut, provided our gut ecosystem is living in homeostasis and our own internal mechanisms can keep it under control. I think a lot of the dysbiosis that we're seeing in patients is easily corrected. And if I can just bring your question back in about sulforaphane, one of the most effective things that we can do with sulforaphane is to use it to address the gut epithelium. And some recent research has shown that it's actually the colonocyte, the epithelial cell lining the colon, which is driving the composition of the microbiome. So that was another big, very valuable revelation to me. And so when we start working with patients who either know they have some sort of dysbiotic gut, or we soon enough find out when the sulforaphane gives them an exacerbation of gut symptoms, I know we're going to be able to sort that problem out. So, you know, I think everybody says good health begins with the gut. I didn't appreciate that when I was in practice. I certainly do now that we've sort of understood what's going on at the gut epithelium. I mean, this single layer of cells lining the gut are quite remarkable. They have such a lot of unique properties that other cells mostly don't have. And once we learn to get them back into normal function, lots of other things sort themselves out. We don't have to cut gluten out of the diet unless the patient is celiac. We don't cut out a whole list of foods with names like histamines and oxalates and salicylates and so on.
And this and that.
Intolerance to plant foods with those molecules, to me, is just an indicator of a very dysbiotic gut. And when I restore homeostasis to the gut, those intolerances largely disappear with few exceptions. So the big problem I see now is so many patients are cutting out these sorts of food families and they end up with this ever narrowing list of foods they can handle.
Totally.
And if they come to a practitioner with only 5 or 6 foods, and that's not an exaggeration, that's not uncommon to see that, they certainly do not have the nutrients necessary to repair the damage. So they're in a pretty seriously severe way when they get to that stage. And a bunch of multivitamin tablets isn't going to make any difference because they're not the signaling molecules. It's other molecules in plants which are the signals that turn on the protective cellular defenses.
Yep, and like the epithelial cells, like I've seen some of the diagrams in some of your charts that you've had, and you know the day in the life of the epithelial lining is absolutely fascinating. They should do a movie on it, really. You know, like we've got we've got so many of these different cells doing different things in these little villi and these Paneth cells and the stem cells and the, antimicrobial peptides and the, this is doing that and that's doing this, and it all has this beautiful harmony to it if it's operated correctly. And so you're working on that, restoring that epithelium intact, is getting that epithelium right first as a part of your first line approach.
Exactly, because the people who have the gut problems have a very inflamed gut. So those epithelial cells are churning out inflammatory cytokines. Those inflammatory cytokines are opening up the tight junctions between cells. I don't call it leaky gut deliberately.
No. Yep.
We're looking for an intact gut barrier. And the reason I don't call it leaky gut is these tight junctions are part of a continuous dynamic where the cells are opening and closing all of the time, depending on what foods they're exposed to and what environmental factors, just as much as foods, and also what biochemical and metabolic factors are occurring within the cell. So this notion that you've got to cut out gluten to cure your leaky gut, quote unquote, it's just so far from the way it works that it's really quite distressing. We've got a whole community of people now who are not only scared of the gluten in wheat, but they're scared of all grains. And we've had books like Wheat Belly by William Davis, an MD not trained in nutrition, which is designed to create weight loss. And now we've got Grain Brain from Dr. David Perlmutter, who's a neurologist not trained as a nutritionist, which has scared the daylights out of people in eating grains. And yet humans have been sustained for eons on grains. And grains, because they're seeds which grow an entire plant or a tree, are a really rich source of micronutrients. So, and then we strip these things out, and we're buying gluten-free breads, which are just pure starch. They're absolute garbage. I've done a seminar just recently on this and looked at the additives. And one of the worst things you will find in a gluten-free bread is what's called modified tapioca starch. The tapioca, I always knew, was just plain starch. There's no micronutrients of any consequence there. It's the modified bit that's the problem. So modified tapioca starch is chemically modified by some pretty nasty processes, and it becomes an emulsifier. And emulsifiers are one of the greatest irritants to the gut barrier and the major factor that opens up the tight junctions.
Wow.
So the patients who are taking gluten out of their diet because they think it's going to upset their gut barrier are now buying gluten-free bread. And I'm not blaming them at all, because the food industry has very sneakily led us down this path, and I need to expose it if I can. So this modified tapioca starch in there opens up the gut barrier. Now they're worse off than they were when they were having gluten, because this bread hasn't got any nutrient of any consequence in it. It's just a filler that's causing the damage that they're trying to avoid.
Yep.
And I think in many cases the patient would be better, as long as they're not celiac, to look at a really good quality whole grain bread that doesn't have the modified tapioca starch. And there's a few other of these emulsifiers. Yep. So the food industry has a lot to answer for, which is, again, why we try and get patients to go back to basics, buy the ingredients, get in the kitchen. It's fun. Yeah. I've been making buckwheat bread and flaxseed bread lately, and they're quite delicious. I mean,
I make mine every day. I love it.
You can never get a more whole grain product than that. I mean, the buckwheat bread, it's basically buckwheat and water, and it ferments itself. It's quite remarkable.
Is there also, I mean, a problem though with some of the grains that are glyphosated up? I think in Australia have now banned glyphosate.
I should say organic. I'm looking at organic, whatever you're going to choose. Yes.
Yeah. I think that
is an issue without a doubt.
Yeah, and I think you've banned it in Australia. Is that right?
No, not yet.
Oh, not yet. I thought you had. I thought, well, they're
No, we're
ahead of.
not so clever.
Oh, well, yeah, I'm hoping we will be one day. I think
Mm,
I think that's a big problem.
it
And
is.
you know, I've got
Because it
celiac.
destroys the microbiota. They have the
Yeah,
shikimate pathway that we
yeah,
use as a weed killer in the real weeds.
yeah, and that's unfortunately very high in some of the grains. So you need to
Mm,
go organic if you're going to have.
definitely.
Yeah, yeah. So those, but these tight junctions they're in flux. They're not, you know, open or closed. That's what you're saying. So
Yes.
but when we disrupt that too much, that's when we start to get the LPSs and so on
Well,
coming out
yes.
into the bloodstream.
Yes, the lipopolysaccharide on the gram-negative bacteria, we don't want them
No.
entering the cells. They get into the circulation, they affect the liver and metabolic syndrome and so on. However, a breastfed baby needs to have its tight junctions open, so that's absorbing the globulins from the mother's milk. And there are various other situations where molecules can be absorbed into the cells. I should also caution at this point, we've also gone down the supplement track of trying to force polyphenols like curcumin into cells by putting them within a liposome or something similar to that. How do they get into the cells? They force open the tight junctions. Yes, you can force curcumin into the cell, and manufacturers. So native curcumin has a bioavailability of about 1%. So you've got to eat an awful lot to get it into the cells. You can get 50, 60% increased bioavailability by using a liposomal form. Why do we think that's a good thing to drive into our bloodstream and our cells, a molecule which doesn't naturally find its way there in nature? At the same time as you're opening those tight junctions to let the curcumin in, it's not the only one, there are other molecules that are in these forms. The LPS, the endotoxin, which is floating around in the gut, it's going to come for the ride as well, isn't it? We're not just letting in the curcumin.
Wow, that's revolutionary. You know, I didn't think of it like that. So, because we know that polyphenols have a positive function in the gut, but more because they're feeding the bacteria in the gut, and the bacteria are producing short chain fatty acids, and that's the way that we're getting benefit from polyphenols, more than just the polyphenol. The structure of these little molecules is way too big for them to basically get in on their own.
There's a couple of factors there. So let's suppose we're at a barbecue and we had some steak, and the steak had been marinated in red wine and lemon zest or whatever. So there's lots of polyphenols in there. That red meat itself may have a fair preponderance of free radicals as part of that meat. Because it's been marinating, you do get a direct quenching of those polyphenols on those radical species. So you're reducing the burden of radical activity that's now going into the digestive tract. You're right, the polyphenols have such low bioavailability, around the 1% of curcumin. That's pretty typical of a polyphenol. There's a few that have a bit higher, but you don't get much in. So step one is they're quenching radical activity if you're having them at the same time as a meal. That could be the polyphenols on your extra virgin olive oil that you're also cooking the meat in. Then when it gets to the microbiome, now the microbiome is digesting those polyphenols. They are prebiotic in a sense that's a little bit different from the starches that we might use as prebiotics. But as you say, you produce the short chain fatty acids. The primary fuel for colonocytes is butyrate, which is one of those short chain fatty acids. A lot of practitioners give glutamine for the gut. Glutamine is good food for the small intestine, not particularly for the large. We need that butyrate to do the job there, to produce the ATP, etc. So in the process of digesting those polyphenols, the microbiota are breaking them down into tinier fragments, and some of those fragments actually are bioavailable. They're now small enough molecules they can be taken in. So we don't know a lot about this, and that's because there are so many different variations on how that large polyphenol could be broken down. the types of microbes in your gut are not the same as mine or anybody else's. So we really don't know, but we do know that that's the way nature works, and we have to accept the fact that some of those will be absorbed into our system and they will have signaling effects when they get there.
Yeah, so they'll become like a peptide almost if they do get into the cell. Would there be?
Well, no, they're not peptides. No, they're just their own little molecular structures.
Yeah, and they will help. So they will be beneficial, and they're definitely beneficial for the colonocytes and the bacteria. And
yes, and the other thing that's interesting too, I mean, I often talk about fermented foods, you know, the kimchi, the sauerkraut, kefir and so on, should be a food group in its own right. And the reason I say that is there's been some research done on some of these polyphenol molecules. So caffeic acid is a very common polyphenol that's found in all sorts of plant foods, from apples to everything. When it's attacked by lactobacillus, it forms a molecular structure which is known to upregulate Nrf2. So that's that switch. So when you metabolize these polyphenols, you're now upregulating Nrf2 as well.
As well. Oh.
So whereas, you know, we teach clinicians about using a molecule like sulforaphane to upregulate Nrf2, if we ate the perfect diet, lived the perfect lifestyle, had some fermented foods in there, we would more than adequately upregulate Nrf2, because that's how nature has designed us. It's just that our modern lifestyle and our modern diet and environment are such that most of us aren't in that category. So that's why something like sulforaphane that just gives you a leg up and gets you up and part to where you should go.
And with the sulforaphane, there's a lot to that story as well, isn't it? Sulforaphane is known to be in broccoli sprouts, very high in broccoli sprouts. But there's so much more to the story of getting sulforaphane into the body, whether you're taking it as a supplement form or if you're making your own broccoli sprouts, which, you know, I do, but I also take sulforaphane precursor supplements, yours, so that I'm making sure. But there's a buyer beware, really, to understand what is the story behind sulforaphane, because I think a lot of people are not clear on that.
And I should explain that. So let's start with the sprouts that you're growing. I'm sure they're beautiful little green creatures.
Yep, amazing.
Yeah, and you know, they're all fresh and lovely, and the freshest vegetable you're probably ever going to eat, because it's growing right there on your kitchen bench. Now, what's little known is so there's actually no sulforaphane in the sprout. There's a precursor called glucoraphanin, and there's an enzyme called myrosinase. And when you chop that up, bite it, chew it, that now means the myrosinase enzyme acts on the glucoraphanin. It breaks off a glucose molecule, and that's what produces the sulforaphane. So you're producing that sulforaphane as you go. When you go to buy broccoli seeds to do your sprouts, you have no way of knowing how much glucoraphanin is in those seeds to start with. And there's actually a 20-fold variation known to be across the seeds. So for a company like us, Cellular, manufacturing a broccoli sprout supplement, naturally we have to search high and low to find the seeds with the highest glucoraphanin content. So that enables us now to manufacture a consistent sprout that has a consistent yield of sulforaphane. When you do your own, you don't know that, because the store where you buy it, the health store or the merchant, wherever you buy it, nobody much ever measures this. It's, it's a seed, it's fresh, it sprouts, it makes a lovely plant. You're getting plenty of folate and other vitamins and minerals from your sprouts. You'll get some sulforaphane, but you'll never know how much. So I think what you're doing is ideal. You're getting the benefits of a very fresh vegetable. If you want a therapeutic measured dose of sulforaphane, you might want to take a supplement where you say, okay, I've looked at the data on this. I need 15 or 20 milligrams sulforaphane a day for my particular situation. And so I'm sure that I'm getting that when I have the supplement. And I mean, we talk mostly to clinicians. So they're dealing with sick people who want to get well. And so they need a measured dose. So there's a dozen or more decent clinical trials that have been done over the years on sulforaphane, and we pretty much know what dose is needed to get a therapeutic response.
Exactly. And you don't know that when you get your broccoli sprouts, but I do think it's also good to, I think it's probably complementary because you're getting the complex of the whole plant, and then you're adding in that you're making sure that you're getting a sulforaphane.
And that brings me to another point. So I think we may be one of the few manufacturers of the supplement anywhere in the world who has a 100% whole broccoli sprout. All we do is we grow it in a particular way. We choose our seed carefully. We extract the water, and you're getting everything there. We don't add anything, and we don't take anything but water out of it. So that's our product. And we can, we test every batch so we know what the sulforaphane yield is. Now, a lot of companies who started out before us produce broccoli, not even broccoli sprouts. They've sort of indicated they were broccoli sprouts. They're actually seed extracts. So they take the seed, they grind it up, they deactivate the myrosinase enzyme. So now you can't produce sulforaphane from that extract. It's basically glucoraphanin powder extract in a capsule or in a powder, and that's what people buy. The trick with this is when they brought these out, they called that sulforaphane glucosinolate, which is not a chemical term, it's a marketing term. And as soon as the buyer sees sulforaphane in the name, they don't know what this other glucosinolate thing is, sounds like it must be all right. They think they're getting a sulforaphane yielding supplement, and they're not. So when you quiz the manufacturers of these extracts, they're usually called broccoli seed extracts. They've stopped using sulforaphane glucosinolate or SGS as much anymore, basically because I've published a couple of papers and I've highlighted this under the buyer beware category. So when you challenge them, they say, oh, yes, it doesn't matter about the myrosinase enzyme because the gut bacteria will break that down for you. And if you have an intact microbiome, which mostly sick people don't have, you can break down 8 to 10% of that. So what you'll do is you'll get about 8 to 10% of the sulforaphane that you get if you have the whole material. And because most sick people don't have an intact gut, they might not even break down 8 to 10%. And in any case, that's not enough to get a therapeutic dose, because when we're talking about nutrigenomics, food talking to our genes, you need a certain dose to activate the Nrf2 switch to get it to start producing all of its protective enzymes. You won't get that from a dose that's too low. So I can't caution people enough about getting fooled by that. And they're not always little companies doing it. Some of the bigger companies are doing it. And some of the practitioner supply companies are doing it. And I think to a large extent it's because this concept of a supplement that has an enzyme in it, which doesn't actually have the ingredient you're trying to get, you've actually got to make it on the fly. There's only 2 plants we know that work like that. Garlic's the other one, which needs an enzyme to convert to the active. And all of the cruciferous vegetables, not just broccoli, they all work the same way. These sulfur-rich plants all work this way. So I think practitioners aren't used to this concept.
No, and I think, you know, like yours is a practitioner only, so you have to work with a practitioner in order to do, you know, this protocol, which is fabulous, because then people get guidance along the way. Because one of the other problems that can happen is that you can have a sort of a reaction to the sulforaphane, and you may have to back right off on the dosing and go very, very slowly. But people mistakenly think, and therefore, you know, working with a clinician is really, really important here, that, oh, I've had a reaction, therefore I can't tolerate this, this is not for me, and chuck it out the window. And actually, if they've had a reaction, that's probably, they need it, they just need to back off.
That's really diagnostic, Lisa. So what sulforaphane does, it has a direct effect, as I mentioned earlier, on re-establishing the gut population, the microbial population. If someone has the sort of reaction you're talking about, what you're getting is you're killing off the bad guys in the gut, the pathobionts, and sometimes you're killing them off at a rate that creates a lot of toxic residue, and now the system reacts to this. It wants to flush it out, so bloating, diarrhea, and so on. And we work sometimes with patients or their clinicians, the clinicians and their patients, where they have to stop immediately and go back to just the tiniest amount of powder on the end of a sharp knife blade. You're obviously familiar with this. Yep. And then we gradually titrate the dose up little by little. So it doesn't happen to everyone, but it happens enough that what you mentioned earlier is always a concern. They go, oh, I'm allergic to sulfur, I'm allergic to broccoli, I can't tolerate this, and I'm just not going to eat it anymore, when in actual fact, you've just diagnosed your own dysbiosis without buying a test for anything.
That's a really good point.
And we just back it right off and we take it slowly. Now, in most cases, a couple of weeks and people will be able to tolerate it. But we have cases where people can take 3 months to get up to that dose. And you go, this is ridiculous. How can this be? Well, it just is. But they are getting progressively better as time goes by. And as long as they're patient and as long as the practitioner realises this is normal, because sulforaphane is such a potent bioactive material, they are getting responses to dosing with that they may not get to a silymarin supplement or a curcumin or something else like that. It's just that sulforaphane has an 80% absolute bioavailability. I said curcumin's about 1%. Most of the polyphenols around about the 1 to 10%. Sulforaphane's about 80%. So it's a different shaped molecule. It's lipophilic, which means it's fat loving. It just glides straight through the fatty membrane of the cell, and it's inside the cell pretty rapidly. And that's why you get such a response. It'll do the same at the blood-brain barrier as well, because the blood-brain barrier operates much like the gut barrier with tight junctions. Mm-hmm. And so there are quite a lot of studies being done on sulforaphane in mental health and in brain function and different things like that, because it is one of those supplements that will glide in, or one of those molecules that will glide in through the gut barrier and starts working immediately. It has an anti-inflammatory effect on the microglial cells, which are in the nervous system. So again, it's this upstream effect. It doesn't really matter whether it was the gut epithelium or the hepatocytes in the liver or neural cells in the brain or other parts of the nervous system. You are trying to have this upstream effect that says, let's try and just optimize the function of every cell in the body to the best of our ability, and then let's see what we've got left after that. Sometimes you don't need to do anything much else. Other times we do need to work specifically on the immune cells, which directly underlie the gut epithelium. So there's a whole immune network in there, and there's sometimes other things we can do there that can help to restore that gut immune interface. So
that's like the second product that you have, the Immune IB, which has got the LTA from the probiotics that have been killed off. So that those so this is so can you explain a little bit why the lactobacillus plantarum, that's 137 I believe is the number, and it's grown to a certain age, and this has a lot of the LTA on the structure of the bacteria, from what I understand. And then that's harvested and actually kill the bacteria. So you're not taking it as a probiotic that's going to colonize. You're using it as a signaling molecule that goes on the toll-like receptor 2 and blocks LPS. Is that right? Have I butchered that?
Perfectly correct. So, so what the manufacturers have done, it's a Japanese innovations. So, and again, this was a huge revelation to me too. Again, this idea that I've got to have a live probiotic, I've got to keep it in the fridge, it's going to replace the bad bugs in the gut. It's not doing any of that. So as you say, it's being standardized for its LTA, lipoteichoic acid, signaling molecule on the outer wall of the lactobacillus. So all of the gram-positive bacteria pretty much have LTA and a number of other signaling molecules. That attaches to toll-like receptor 2 on the gut epithelium, and that now signals to the underlying immune network. And long story short, that has the ability to normalize immune functions in this way. So it helps infection control. It can similarly help destroy cancer cells, natural killer cells, and so on. Wow. It down-regulates the allergic response, down-regulates inflammation, and down-regulates autoimmunity. So when you get that gut immune interface in homeostasis, those are the functions that you're able to normalize. This was extraordinary when I discovered this. And the other advantage of using a heat-killed probiotic is those patients who claim to have the histamine reaction and do, they usually can't tolerate a fermented food, because those fermented foods, which have these lovely lactobacillus, reactive to them. So this way you get the advantages and none of the disadvantages.
So I've got that bit of a problem with histamine. So, you know, this is in family members with the same sort of thing. When you give them a probiotic, they're off to the races with all sorts of problems, you know. So this is a beautiful thing, and it's a lovely synergy then between the sulforaphane and that, and so this would be, because your immune system is you know 80% or something resides in the or around the gut.
Just under the gut. You're right.
Yeah. So this is really a 1-2 punch for health in general. And when you say like crossing the blood-brain barrier, like the range of ailments that this can, you know, like we don't need to know the names of the diseases that you, like you said, when we're helping people, but it would be interesting for people to know, like, what is this going to help me with? So if this is so powerful, what systems is it going to have an impact on? And what can I, you know, if I've got thyroid problems, Hashimoto's, if I've got adrenal issues, is that going to help with those, or IBS or Alzheimer's or dementia or TBIs, or, you know, can you give us a few things where studies have been done, diabetes, you know, where it's been done on, and we've got some clinical research on?
Well, the clinical trials, so there's a fair bit being done on just detoxification of environmental chemicals like motor vehicle exhaust fumes.
Very powerful.
I think we're all exposed to that. Aflatoxin, ochratoxin, and here's another case where I'm running into people all the time who all of a sudden have mold issues. Mold issues have always been with us. Now we've got this whole syndrome now and this complex process that patients seem to think that they have to address. I mean, I live in Queensland, Australia. I'm not in far north Queensland, but it's very humid there all year round, and people wash all the mold off their walls twice a year. Wow. They aren't all suffering from mold issues. Why not? Because a healthy immune system can address that. So again, I mean, I'm just going to digress a little bit, because what's common in the world of treating the gut these days is practitioners wanting to give antimicrobial therapies to kill off what the stool microbiome report told them was a pathogen or a pathobiont. You're also killing off the commensals. The commensals are the good guys. We want them there. We don't do any kill therapies at all. And the reason we don't is one of the cells lining the gut epithelium, you mentioned before, the Paneth cells.
Paneth cells, yep.
They produce a range of antimicrobial compounds, including defensins. The important thing about them is they're selective. They kill the pathobiont and they don't do anything to the commensal. Amazing. How clever is nature?
Much more clever than we are.
That's why I say we don't have the ability to micromanage to that extent. So if we just go upstream and we go, we're just going to give Mother Nature a toolbox and stand back and let her do her thing. The biochemical pathways involved in all of these processes are so intricate and so complex, and constantly modulating from one moment, one nanosecond to the next. How do I know whether nature wants more glutathione at the moment, or it doesn't need it now, it needs less? If I go pushing glutathione into the cells, what am I doing? I don't know what I'm doing. Whereas if I give Mother Nature the toolbox, it says glutathione synthesis and a range of other glutathione related enzymes are all part of the Nrf2 activation process. And that activation process has got its own checks and balances in there. So the cell goes, no, I don't really want that at the moment. Just ignore you. Oh, an hour later, yes, I do need that now. So this modulation, I prefer that word to regulation and control. Modulation is just simply saying, I'm just observing this, it's coming and going, it's in a dynamic state. It's like the tight junctions, they're in a dynamic state. They open and close gently whenever they decide that they need to do this, not when I decide.
Yeah, and this is like not just true with pharmaceutical interventions, which definitely force pathways and cause always these knock-on effects, but also even with some of the natural compounds, like, oil of oregano, for example, that we use for, antimicrobial purposes, can actually be, destroying some of the good guys as well.
Very much. Just because they're plants, they're not necessarily all that gentle. I mean, look at grapefruit seed extract.
Yeah.
It's a very destructive effect on the gut microbiome. So I know a lot of people find it really difficult to believe what I'm saying when they're so used to getting a report and it says, right, these are the bad guys in your stool microbiome, and you're going to go, right, what kills that? Good, this, and this.
It'll be easy.
That is not how nature works. It never was. It probably is never going to be. And I see, long drawn out processes where often patients are getting sicker and sicker because they're reducing the diversity of the microbiota living in the gut. Whereas we're saying we're going to let nature use its own antimicrobial defenses, and we're going to now start introducing prebiotics gradually as the patient can tolerate them. So once we've gotten the homeostasis at least partially restored, once foods to which a person was intolerant no longer are reactive. So we can have a little bit of psyllium seed, we can have a little bit of resistant starch, whatever it happens to be, and little by little we're now feeding the diversity of that microbiome. And it's been shown that, even if you've had a bad gut for a lot of your life, there are still residues of those important microbiota living in little niches within the gut. And if you start feeding them, there's enough of them there, they'll start repopulating. And people have found this. They've thought, for years, I don't have this bug, I've killed it off. But often you can get quite remarkable recovery just by giving Mother Nature a toolbox, essentially.
Yeah. And giving it the right things in the right sequence. And, when you go to your third product, the Florogenics, that would be bringing in those prebiotics at that point. And
so that's a starting point. But I mean, sometimes we don't even need the supplement. Sometimes I get people making their own homemade potato salad. If you take small potatoes, leave them, the skin on them, the little pink ones are good. Cook them, leave them overnight. The starch molecules rearrange as that potato cools down.
Wow.
And that now forms a very effective prebiotic that you can use to feed some of the microbiota. So that's a very gentle way of restoring the microbiome bit by bit.
You have to put a recipe book out. Dr. Christine.
Yeah. I mean, that's where the seeds, the whole seeds, the flax seeds and the buckwheats and all sorts of
All
seeds.
of that can come in.
The more variety you have in the diet, the greater the diversity you have of the microbiota. They don't all like to eat the same thing. They eat different things, and we feed them, the better they get.
So that's what another problem that I see with a lot of people is they have restricted their diet because they're told this is bad, that's bad. And, you know, sometimes you do get to the point where you think, what the hell do I eat? Because everything's bad for me and the environment's bad. And then you end up in the stressed out state because you can't eat anything and you can't go anywhere or do anything, basically. And so you, by freeing your mind of that, to a large degree, obviously processed food, probably out, you know, anything with chemicals, additives, all of that sort of crappy stuff.
That's a given. Yes.
Yeah, that's a given. So, but if we can go with whole foods, real foods, organic real foods, then, you know, take your pick, and the more diverse your diet should be, then the more diverse hopefully your microbiome will be. And the diverse, like a rainforest, is better than a one that's got eating the same. You know, you see a lot of people, you know, they're on a keto diet or something, and they're just eating broccoli and chicken breast. You know, like it's gone too far when you're not having a variety of, you know, the beautiful foods that are available to us, and sprinkling, you know, having a little bit of garlic in your cooking is different than having, you know, a garlic extract or a oil of oregano. Having a bit of oregano leaves sprinkled on your salad or something is different than when you're doing a very
well, there's not, if you're talking about the oregano leaves, there's not much oil in them. Whereas when you take an oregano oil supplement, you have a very concentrated amount. Again, if it's not possible for me to eat enough of that food that I can get out of a supplement, perhaps I shouldn't be eating it. I mean, that's a pretty simple guideline.
Your principle, yeah.
It's like 1,000 milligrams of vitamin C as a supplement. That's 16 oranges, for example. Would I eat 16 oranges every day? I could. I'm probably not going to do that.
Yeah, I did have a question about that because I've been a huge fan personally of intravenous vitamin C in relation to cancer, and done a lot of interviews with the scientists in the world of cancer research and intravenous vitamin C in particular for that and for sepsis. Is it a different, because it's a pro-oxidant when it
totally different process, totally different mechanism.
And you're in extreme situations, we're talking here.
I see intravenous vitamin C as probably a safer form of chemotherapy, if we can simple nutshell like that. Yes, it's highly pro-oxidant, and that's what it's supposed to be. But unfortunately, a lot of the studies get conflated, and individuals see, you know, somebody had 10 grams intravenous C, I'm going to have 10 grams of tablets.
Oh, that doesn't work. It
doesn't work. And the other thing that's not well known is you've got a saturation level of about 400 milligrams of vitamin C a day is as much as you can reasonably absorb for most people. You can get that out of food. You don't need those mega doses. This is part of the old science that comes from the 70s, where the old masters, Pauling and some of those people way back then, who thought that that was what cells wanted. And there are mechanisms that you can describe. So Abraham Hoffa, for example, used really high dose vitamin B3 in schizophrenia. So he was driving a biochemical reaction to completion to try and force certain enzymes to work. We now know nutrigenomically you don't need to do that. You use signaling molecules out of plants, which is how nature does it. And you can get the same response without doing it that way. So that's what we thought back then. And, you know, as time's gone by, we've learnt more. Our understanding has grown. And as I mentioned earlier, the completion of the Human Genome Project in the early 2000s was pretty much a line in the sand where we had to start looking at how cells function in a different way. And so most of my work post-clinical practice has been in that post-genomic era, if you like, where we've now started to look at the signaling molecules that are in plants. It's not the vitamins and minerals, it's 5,000 odd other molecules, which includes polyphenols and carotenoids and
this complex.
isothiocyanates and so on. You can't get that out of a multivitamin pill. And so this is where people on these highly restrictive diets can get into so much trouble. They go, look, I'm taking folate and I'm taking my multi and I'm taking zinc and I'm taking glutamine. They're still sick because that's not activating these intracellular switches that nature uses to upregulate its own defenses.
Yeah, and I think, you know, like we just have to come at things from a humble point of view, that we're just still scratching the surface of the complexity of the human body and the way we work, and in every decade that goes by we're uncovering more, and we'll be able to, you know, help people in much more efficient ways, like with your protocol that's really, you know, taken it to a next level. And simplified it. That's what I've been, you know, so excited about, is it simplified a lot of the things for me. And I think, you know, there's beauty in simplicity. If you can have just a couple of concepts that you're getting that are really upstream of all the other stuff, that you don't need to be a cardiologist or a gastroenterologist or a neurologist or whatever.
Probably better that you're not.
Yeah, exactly, because then they have more and more specialized knowledge about less and less, and then you need those specialists, don't get me wrong, for when you're in extreme cases, and we're talking more for the person who's not in those extreme situations. But when you can go upstream and be in this preventative space, which is what I always preach at people, is to try to be preventative, try and work out what are the, you know, I do a lot of genetic testing and what I do in my company, and I do like to know the genetic predispositions and then look at the epigenetic side of it. You know, how are they actually expressing, and how can we marry the two to give that person an ideal lifestyle framework to work from. But we're still not, you know, just because you have the MTHFR, you know, genetic SNP on the whatever, it does not mean you are sick. It does not mean that you have a disease. It just means that you might need to be a little bit more careful that you're getting, you know, certain things going. And if you feel like you're not well, then maybe going and getting your levels tested, you know, or taking an intervention that will help support that methylation. It's not a, you have this, therefore you are, you know, X, Y, Z. I mean, I have very poor GST genes personally, so which is the, you know, the glutathione family of genes. I've got an absolute disaster. So for me, anything that supports that Nrf2 pathway and the glutathione and all of that sort of thing is very important to me, because I know I have a genetic predisposition to having problems with detoxification and so on and so forth. And I'm the canary in the gold mine. And I've managed to get myself to a level now, from being quite a severe asthmatic, or very severe asthmatic as a child, and having all sorts of allergies, eczema and all of that. So I don't have any of that anymore.
Well, that was back to your clinical trial question. So we got sidetracked with that, because asthma and emphysema,
yes,
two other conditions for which there's been sulforaphane clinical trials.
Yep.
Along with autism. There's been a couple of studies on autism. Who would have thought?
That makes sense.
Helicobacter pylori, the gut infection. So that's not related to that's not related to Nrf2. Sulforaphane has another mechanism by which
that's the urease.
That's right. And we don't want to eradicate Helicobacter. We just want to bring it back under normal control. Most of us have Helicobacter, but we're not necessarily sick. And there's been studies on arthritis. I mean, theoretically, as I've said, I don't really care what the disease name is, because I'm trying to optimize the function of the cells in that person in front of me, and whatever their particular predisposition, their weaknesses are, their signs and symptoms, we would hope that all, or at least some of those, will disappear just by normalizing cell function. And with the GEM protocol, what we say is the science is complex, but the implementation is simple. And in fact, sometimes it seems so simple that some practitioners are going, how can that work?
Yeah. Don't I need a bit of this and a bit of that on top? But I heard one practitioner talking about her experiences, and she said basically 95% of people who come through the door, they're on the GEM protocol before she's done anything, because she's found it to fix such a wide variety of problems. And then, as you say, dig in deeper into certain things once you've got that, you know, that cell in a homeostatic state, hopefully, and then you can fine tune with other things. But
it's
that's
also
quite
part of teaching patients how to maintain that state of well-being.
yeah.
And it means you have to change your diet. There's no shortcut to this. There's, you know, if a patient is really not prepared to get their diet under control,
You
we
can't
can't
do
really
much.
fix this in the
No.
long term. But
No.
I think a skilled clinician who can work with food and talks to the patient, what sort of things do you like and dislike? We can pretty much work an eating plan around maintaining the principles that are needed, but also taking into account, you know, I don't like asparagus and I do like beetroot or whatever it is, and we can work with that.
Mm-hmm.
I mean,
Yeah.
we don't all like all the same things, and we don't have to eat according to the plan 100% of the time.
That's the other
I mean,
thing.
even when I was in practice, I would say to patients, we have the 90% rule, and it's usually the 10% is going to happen on the weekend. When you're out, eat what you like.
And we want to
Within
live, you
reason.
know, like I do think we, you know, and if we panic all the time about everything that you're sticking in your mouth, you make life pretty miserable. And it's, you know, like
I
you
mean,
want
in
to
the
enjoy.
short term, if you're a diabetic, I'm not
Yeah.
I don't give much leeway on that until
Yeah.
we get everything back into control. So to me, it's a lifestyle. It's not impossible. And if a patient feels the benefit and then they stray off the track, they'll realise after a while, yeah, I've broken this rule and that rule. And they'll often go back to the clinician and go, can you just get me back on that again? Otherwise, they'll do it themselves. So it's just learn as you go, in fact.
Actually, on that point, is there a point where you like should go off sulforaphane if you are taking it as a supplement or even as a broccoli sprout? You know, is there such a thing as having too much Nrf2 activation?
Because we have those modulatory pathways built in.
Right.
As I said earlier, if we ate the perfect diet and lived the perfect lifestyle, we are continuously upregulating Nrf2.
Mm-hmm.
And nature will go, okay, we'll just leave that alone today, but yes, we need it again tomorrow. So those checks and balances are built in. So no, you don't need to stop taking it. I mean, people do. I mean, I've had, in a paper that I published recently, I've got some photos of some skin conditions, psoriasis and eczema. For example, that psoriasis patient that's in there, I've got photos once a week of his elbow recovering over 4 weeks.
Wow.
And this was back from 2011. I wasn't in practice then. He was actually the agent who was selling our house at the time when we got talking. And because he was an agent, he had white shirts on every day and blood was seeping through his elbows and he was embarrassed. So that's how he became my surrogate patient for a time. So he got such an immediate response from taking one of the sulforaphane yielding supplements. He said, would you like me to take a photo every Monday? Yep, sure, please do.
Yeah.
So I've retained those photos and I still talk to him. He probably 3 or 4 times a year, he will go back on to about 2 months of one of these supplements, and then he's all right.
Yep.
And he manages that. You know, he starts to see his elbows or other parts of his body scaling up again. He'll go, I need to go back on it, because we know psoriasis has a strong genetic component. So we can't change that gene, but we can change the way some of those genes are expressing themselves.
Yes.
And that's what we're doing with him. So he'll stop-start it according to his own requirements. And that's because he understands now what he's trying to achieve and what works for him.
And there's quite a lot of research around cancer, and without getting into specific, you know, types of cancer, but you know, just as a preventative approach, you know, this would seem to me like a good idea to be putting into your regime if you're, you know, concerned or got a family history of cancers and so on, maybe to put this in your approach, you know.
Yes, and you mentioned doing your gene profile and your GST genes. There's another gene, a phase 2 gene that should be in your profile called quinone reductase.
Yes.
And quinone reductase is an enzyme that is at the very last step of your detoxification processes, just before DNA is about to be impacted. So if you're detoxifying some nasty petrochemical, let's say, and you go all the way through, your GST genes are letting you down a bit, they're not working as well as they should, you get to quinone reductase. So this is a fork in the road here. So either you will now mutate your DNA because that nasty chemical whacks onto your DNA, or a healthy quinone reductase will grab that partly broken down toxin, drag it back to the beginning of the phase 1 detox pathway or phase 2 and represent it again. So gradually you're breaking that down. Oh. That's the power of prevention. And quinone reductase is an Nrf2 target gene. So that is a very powerful preventive. And I just think nature is brilliant. So it's sort of the last step, and it grabs
a second chance
to the beginning again, go again, and you'll finally get broken down and removed from the system.
And that's important for estrogen, you know,
same
the quinones,
pathway, yes, exactly.
And also for the dopamine pathway.
Yes.
So, you know, like with dopamine being broken down, it can go to that quinone.
So oxidized dopamine often, you know, will occur unless you can break that down further. So there's just so many different pathways that are impacted. And if we can optimize the function of those pathways, even if we don't fully understand how they work, that's the power of food. That's food as medicine.
Are there any other herbs and things that are also that create the sulforaphane in the body, or is it only the broccoli cruciferous family?
So it's only cruciferous vegetables. It just happens to be that the broccoli sprouts sort of the most potent of them.
More powerful than the full vegetable.
Arugula or rocket, that's another one in that same family, which produces a similar kind of molecule called arusin. Cabbage produces cinegrin, so it goes. All of the cruciferous vegetables all have the myrosinase enzyme. They all contain a precursor that gets produced when you eat it. When you cook the vegetable, you do kill the enzyme, so you lose some of that. So you need to
raw
eat some
broccoli, everybody.
raw, and you can have some cooked. There are other molecules. I mean, because I'm saying to you the perfect diet upregulates Nrf2, pretty much all plant phytochemicals have some ability to activate Nrf2. When you put them all together, you're going to get sort of an additive or possibly even a synergistic effect. We don't know exactly how far that goes. But I have also published in some of my sulforaphane review papers charts which look at the ability of sulforaphane to upregulate quinone reductase. So that's that protective DNA protective enzyme. So you see sulforaphane's way up there above the rest. The next one down's penostrobin. That's a molecule we don't really hear of, but it's in galangal, and galangal's an Asian rhizome that's often used in cooking. And then they pretty much drop pretty rapidly. Astragal or andrographis is in there next. And then the others like the curcumins and the silymarins, they're pretty low on the list. And it's interesting because silymarin or silibin, St Mary's thistle, has been used traditionally as a liver detoxifier or a hepatoprotective, but its effect is very, very minimal compared to what you get from sulforaphane, andrographis and penostrobin.
Wow. What about rosemary? Is that that's an Nrf2 upregulator, but through a different molecule too, isn't it? It's not through the sulforaphane.
Yes, and you don't. You've got bioavailability issues again here. So rosemary oil is a very good antimicrobial, and they're using it in the food industry on packaged meats and things like that now. So it has other properties. I mean, I'm really all in favour of encouraging people to use as many herbs and spices as possible, marinating foods, you know, making all sorts of interesting, tasty, different foods. And I think once people get the hang of how to do that, it's remarkable how many additional signaling molecules you're getting in your diet.
Yeah, and we can put them all together and hopefully they'll have a synergistic effect. And that's the next 30 years work probably cut out right there. Dr. Christine, you've been absolutely fabulous today. I mean, I could talk to you for hours and elucidate 1,000 more things, but is there anything that major that we've missed out that you think, yeah, we need to say that too, that we haven't
just
covered?
Back to the cancer story. So most of the sulforaphane research is done in prevention, which I think you alluded to. The issue of cancer treatment is a totally different one, and I don't think we really have any definitive answers on that. So I just want to make sure your listeners realise that I'm not promoting sulforaphane as a cancer treatment.
No.
I know there are lots of people who do take it and claim that it's helped them, but we just don't have the evidence for that. But certainly prevention, there's brilliant research on prevention.
And there's a good mechanism there that we can see why it would help in the, and it's always with cancer, it's sometimes it's, you know, something that's fabulous to take as a preventative is not necessarily in when you've got an active case of cancer, unfortunately.
And I think one of the real reasons for that is by the time somebody has cancer diagnosed, there has been a whole chain of protective mechanisms have failed one by one, and the patient didn't know, maybe some vague symptoms that they ignored. Finally, by the time double-stranded DNA has been mutated, you don't have the ability now to repair the double-strand mutation. That's when trouble really hits, and we don't have a really satisfactory way of solving that problem.
We need more work done in those areas. Yeah, I think that's a really important thing to bring up. It's just absolutely fascinating. I think if you're not having sulforaphane or broccoli or cruciferous veggies in your life, you better start taking them. And if you've got access to a practitioner that can do the GEM protocol, and where can people find, do you have a directory or anything like that of people?
Yes,
that people can work
first
with?
of all, to sort of understand a little bit more about the protocol, if your listeners go to the CellLogic website, cell-logic.com.au, there's a section called Learning Centre in the top menu. Drop that down and there's some general information about GEM. If it's a practitioner, they will have to register to get that information because it isn't all available to the public. But there are 3 videos on that general information which explain different aspects of what we've been talking about today. And then if they go to the contact section in the website, we've got a directory of practitioners who've been trained in the GEM protocol. And most of those practitioners work online now. Some of them work
so you can
face-to-face in clinics. It's a different world now, but
it's fabulous, really, because
Zoom changed the world.
Yeah, it did, and that's one positive thing to come out of the last few years. Well, Dr. Christine, thank you so much for being so generous with your time. I know I've gone a little bit over, but I really appreciate all the hard work that you've done and the amazing science that and products that you've brought out. This protocol that you've spent years working on, researching, doing the hard yards to bring it to people, and it's helping so many people. So thank you so much for everything you do. It's absolutely amazing.
Thank you so much, Lisa, for having me on your show.